Good morning. Today we are going to see the concept of motion under gravity. You can subscribe YouTube channel Civil Engineers Technical Hub, and in this in playlist of this channel you can have engineering mechanics subject, and in this playlist you have number of videos related with this engineering mechanics. Now you can see here, so portion we have covered. So basic concept we have seen, equation of motion, problems from constant acceleration, and now we will go with motion under gravity. So now motion under gravity is actually is very easy, I can say, but you have to understand it very clearly. Once you understand it, then you can solve problem of this motion under gravity very easily. And now, motion under gravity, actually, this is part of problems from constant acceleration. Constant acceleration. Now, in constant acceleration, which we have seen in last video, value of acceleration is changing. But in motion under gravity, my acceleration that is equal to g, which is 9.81 meters per second square, and this is downward. Now, while going for this motion under gravity, you have to keep in mind where motion is there, in spite of that motion, it is upward or downward, my sign convention should be same. Sign convention we have same, whatever motion is there. So my sign convention, I will say upward, it may be velocity, it may be displacement, so we have positive. So I can say all quantities, or I can say displacement, then I can say velocity, I can say distance, all if upward, we have positive. If it is downward, we have negative. It is very clear. So my value of A is always minus 9.81 meter per second square. If it is coming down, then also I am going to consider value is minus 9.81 meter per second square. The main problem, student confused with this, they are not in position when we will consider plus, when we will consider minus. So whatever concept we are going to see today, in this, you should be very careful. You have to always consider this value of acceleration, and that is always downward. So, and that downward means we are going to consider that value that is equal to minus 9.81 meter per second square. Now, how we will go with these problems then? So now I will consider one problem. So we have body, I will say, or a ball we are going to thrown upward from this point. So we have some velocity. So I have velocity as 10 meter per second. Now it is in upward direction. Ball will go up to a certain height, and what will be maximum height? So maximum height we have where my value of V is 0. So the point from where your motion start is always mentioned as initial position, and the point where it stops, that is your final position. Now I will consider in upward direction only, and then we have, this is my final position. Now I have this initial and this is final. Now what is displacement? So displacement is, so should be very careful again with these terms. Displacement, distance between initial and final position. Distance between initial and final position. Initial and final position. Final position. What is distance? Distance, this is path traced by the particle. Distance, path traced by the particle. By the particle. Now we should be very careful, try to understand the concept of this. So now you can see, we have, let us consider this distance as y. So we have this as y. So my value of y, that is positive. Now again I will consider some cases. So you are going here, which is my initial position. Ball will go up to a certain height, or I can say maximum height, and then it will come back, and we have somewhere here. Now my ball is here. So I have this as final position. Then what will be? Again, I have displacement y, and this displacement is positive, which is initial to final. If I will say this distance we have y1, then what will be distance? Displacement is y. Displacement, distance between initial and final position equal to y. What is this distance? This distance will be y1 minus y. Now, what is distance cover? So I have distance. This is equal to. Now it will first go path traced by the particle. It will go up. So this will be y1. It will come down. So again plus y1 minus y. Plus y1 minus y. So what is distance? 2y1 minus y. Displacement is y. Distance traveled is 2y1 minus y. So try to understand the difference. Now we will consider another condition. So ball will go up. It will go to maximum height, and then it will come back. And then its position is again same. So my initial position is here. My final position is here. So let us, I will say this will be y1 distance. So initial and final distance along the same line. What will be displacement? No displacement is there. So displacement equal to 0, because what is displacement? Shortest distance between initial and final position. I am saying shortest. What is distance? So you have to trace the path traveled. I will go up, it will go to this point, that will be y1, and again it will come to initial position, that is again y1. So what will be my distance? My distance is 2y1. Now let us, we will consider again one condition. So it will go up, it will be at this point. So this is my initial position. And then it will come down and it will go below my initial position. Now this is final position. You may say how it will go below. So if I am on a tower and if I am going to throw any object, then it will come down or at the foot of the tower. So that is below initial position. Then I have, this will be distance y, which is between initial and final position. Now what is displacement here? So I have displacement that is equal to now minus y. Why minus y? Because initial position is always considered as origin. Initial position we are considering as origin. So if my final position is above initial position will be positive, and if it is below initial position, means it is below origin, then it is negative. And then this again I will consider y1, this will be y1. Then what will be distance covered? Then I have to travel the path, I have to trace the path. So y1 up to maximum height plus again y1 and then plus y. Now when I will say distance, it is scalar quantity. And when I will say displacement, it is vector quantity. So in scalar, it is below origin, above origin, below origin, that doesn't matter. We have to just trace the path and add all the quantities related with your path, and that will give you distance traveled by the particle. So if my velocity is upward, then I have that value as plus, and if my velocity is downward, then my velocity is negative. My value of A is always minus G, which is minus 9.81 meter per second square. Now, whenever we are going to be with this chapter, and whenever we will ask, if I will throw a particle from a tower, and when it will reach ground, then what will be its velocity? And answer of the student is always that is 0. And if your answer is 0, you will get marks 0. Because velocity at the ground is not 0. You have that velocity maximum along this path. Maximum in this path, you can say. Now you may surprise. So you try to understand, if your mobile, you are going to throw on ground from first floor, what will happen? You are in position to go to ground and collect it, and possibly you may repair it. Then you can do the same thing from second floor. Then again chances you may repair it with more cost, because from first floor 3-4 parts will be detached from your mobile. When you are in at the time of second floor, again number of parts increases, and if you are higher side, then you need not require to go ground, because all parts are detached. Means as you are going towards down, your velocity, that is, increases, and you have maximum velocity when it reaches at ground. So you should be very careful with this one. Then you will say it becomes 0. Becomes 0 after impact means you have to study, that is impulse moment. And after that it becomes 0. When it will just touch the ground, its velocity is maximum when it touches the ground. And after impact, that velocity becomes 0. Now, very simple, you can see, if I am going to release, just I am saying a release. So when I will release it, my initial velocity is 0. So let us, I will consider it will travel distance s, and what will be my final velocity. Then if we will say initial 0, just we are going to drop any object, and when you will drop or when you will release, your initial velocity is 0. If we will say final velocity is also 0, then how it will cover distances? And if it has to cover distances, means it should have some velocity. So we have u0 and we have value of v. And now if we will write v square equal to u square, I already mentioned we have this formula, but in this we have v square equal to u square minus 2g, because we have a is minus g. But always keep in mind, you have this as initial position. You have this as final position. So instead of S, I will say it will be Y. Now, initial position is upward. Final position is below initial. What will be displacement? This S is displacement. And what will be a displacement, plus or minus? So yes, it is minus, and therefore I have this also minus. And then I will get it as V square equal to 2GY. Now we will get V equal to, should be very careful, we should have minus plus minus 2GY. Now again question, plus or minus. Now it is obvious, when my particle comes in downward direction, my value should be V equal to minus 2GY. And then the problem becomes very simple. So likewise, you have to keep in mind initial position, final position, upward plus, downward minus. And G is always minus 9.81 meter per second square. Now, if I will say a simple problem, you are going to throw a particle by 10 meter per second. What will be its velocity when it will come on ground again? Now, problem is very simple. So, U is 10 meter per second. Then what will be value of V? Now, what is displacement? So, I will say Y. I have initial position here. I have final position here. Then what will be value of Y? So, Y is 0 because distance between initial and final is 0. Then what is formula? V square equal to U square minus 2GY. And now Y is 0, so this term is not there. And then what will be? V is equal to plus minus U. And now as it is in downward, so I have V equal to minus U, means my velocity is 10, but it is in downward direction, minus 10 meter per second, or I can say 10 meter per second, which is in downward direction. So we should be careful with this. And once I am through with these sign conventions, which are related with your motion, then I can solve problems very easily. Means I am going to modify the equation which are for constant acceleration. I have equation V equal to U plus AT. Now for motion under gravity, I will have V equal to U minus GT. Now I have here S equal to UT plus half AT square for motion under gravity. My equation is changed. I have S equal to UT minus half GT square. And last I have V square equal to U square plus 2AS. Here it becomes V square equal to U square minus 2GS. And in all this, my value of G is now plus, be very careful, plus 9.81. Why plus? Because I already considered A equal to minus G. We have taken sign convention over here. And therefore, always put value of G is 9.81 meter per second square. If you have any doubt, you can contact on this 9922932711 or WhatsApp number 70388 You can put message, I will reply for it, but use sign convention. Do not be with sign convention when motion is upward, G is plus, and when motion is downward, then we have this value that is minus. So these sign convention will be problematic while solving the problems. You may confused with this. So be always with sign conventions in motion under gravity with three equations. Upward we have plus, downward we have minus, which is related with your velocity. And related with your S, you have to compare initial position with your final position. If initial position is below final position, then my value of displacement is plus. If my initial and final is along same line, then my value of displacement is 0. And if my final position is below initial position, then my displacement is negative. Once we are through with these sign conventions and these three equations, we can solve problem in 2 to 3 steps. That's all. So now we will stop here only. Now we will solve the problems from question papers in next video. So thank you.